Alright, it's time for the solutions for the explicit functions from arithmetic and geometric sequences. So on the front side, you write the next three terms and then write your function. On the entire front side, they're all arithmetic sequences, and so your explicit function is going to be of this form. You have basically two blanks to fill in. You put the common difference there. You put your initial value there, and you'll be good to go. So I'm going to start with that on all of these. A sub n equals something times n minus 1, and plus a number on the end. Alright, so there's how all these ones on the front are going to look like. So on number 1, we have a pattern here of adding 7 each time. So if you add 7 again, you get 37. Add 7 again, you get 44. If you add 7 again, you're looking at 51. And that's going to give us a common difference of 7 because we're adding 7 each time. And our initial value is going to be the first number of sequence, which is 9. So 7's going to go in front there, 9's going to go there, and that's your form of your explicit functions for arithmetic sequences. You actually can simplify that down. If you distribute the 7 through, you'll get 7n minus 7 plus 9, which if you combine like terms, you're going to get just negative. You're going to get 7n plus 2. So realize that you can simplify that down a little bit to get 7n plus 2. On number 2, we have a slightly different pattern, which is going to be subtracting 7 each time. So it's going down 3, negative 4, and negative 11. So there's that. And so our common difference is going to be negative 7, because we're subtracting 7 each time. Our initial value is going to be 31. So those are our two numbers over here. We're going to put in negative 7, put down 31, and we can simplify that down. If you distribute that negative 7 through, you're going to get negative 7n. Negative 7 times negative 1 is going to give me positive 7, plus the 31 is going to give me positive 38. And my next one, we're getting this pattern here of adding 4 each time. So if you add 4, you get 10, then 14, then 18. So our common difference is 4. Our initial value is going to be the first number in the sequence, which is negative 6. The common difference goes in front of n minus 1. Your initial value is going to be here on the end, plus negative 6. You can distribute the 4 through, and that's going to give you 4n minus 4 plus negative 6, totally getting negative 10. And on number 4, we're getting this pattern here of adding 3 each time. So it's going to give me 4, 7, 10. That should just be a 10. And so my common difference is that number that I'm adding each time. My initial value is the first number in the sequence, which is negative 8. Common difference goes right there in front of n minus 1, and my initial value goes on the end there. You can simplify this one down. If you distribute that 3 to get 3n minus 3 plus negative 8 is going to be negative 11, or subtract 11. And that's the simplified version. Moving on to the next section, on 5, it has this pattern of adding 4 each time. So we're going to get 28, 32, 36. So our common difference is going to be 4. Our initial value is going to be that first number in the sequence, 12. So 4 goes in front of n minus 1, 12 goes on the end. So there's your basic explicit function for an arithmetic sequence. You can distribute that 4 through to get 4n minus 4, but I'm going to combine that with the plus 12 to get me plus 8. So there's a simplified form of it. On 6, we're getting a pattern here, getting lower and lower and lower, which is subtracting 2 each time. So we're going to get negative 5, negative 7, and negative 9. And so my common difference is going to be negative 2. My initial value is that first number sequence of 3. So negative 2 is going to go in front. Negative 3 is going to be there on the end. There's the basic form, And you can simplify that down. If you distribute your negative 2 through, you'll get negative 2n plus 2 plus the negative 3, because it'll give me negative 1 there. Yep, so that's, oh, what am I talking about? I messed up on the 3 here. It's just positive 3, which, when you do negative 2 plus 3, it's going to give you a positive 1. There we go, that one's fixed. And on 7, we actually have the same pattern as number 6, of subtracting 2 every time, so our common difference is negative 2. Our initial value is going to be the first number in the sequence, which is 14. If you keep subtracting 2, you'll get, not negative 6, you'll get 6, 4, and 2. Our common difference goes in front. The initial value is going to go on the end there. There's the basic form ready to go, and you can simplify that down if you distribute the negative 2 to get negative 2n plus 2 plus 14, going to come out to be plus 16. So this is a simplified form, and let's move on to the back part. All these ones are geometric functions, and so you're going to write the explicit function for geometric functions. You notice I already have some answers on there because they're actually kind of a pain to calculate. I had to put them in a calculator. I couldn't just do it in my head. So I have some of those already there, but I'll explain how I got them in just a little bit. First, let's look at the function here. That is a pattern of timesing by 2 each time, so our common ratio is going to be 2. Our initial value is going to be the first number in the sequence, which is just 6. And so, our explicit function is going to be a sub n with geometric sequences. They're set up like this, where this number is the initial value, this number is the common ratio, initial value, common ratio. There's your explicit function. And now you can get the rest of these, a sub 3, a sub 5. To get a sub 3, you just go to the third term in the sequence, which is 24. To get a sub 5, I'm going to take this last number here, number 4, and I know the pattern is times by 2, so I'm going to take 48 times by 2, which is going to be 96. Let me circle these. To get a sub 10, I'm going to take my explicit function here and put a 10 where the n used to be, and once you calculate that, you'll get 3072. To get a sub 15, you're going to plug in 15, and that'll give you 98,304. So there's number 1. On number 2, we have an initial value of the first term in the sequence, which is 180, and the pattern on this one is not timesing by 2, but rather dividing by 2 each time. And so if you want to divide by 2, that's the same thing as multiplying by 1 over 2. And so now we have that information. My explicit function, which is going to be a sub n, is initial value times common ratio to the n minus 1 power. And that one's it, and it's ready to go. If you want to get a sub 2, you just go to the second term of the sequence, which is 90. If you want to get a sub 5, we'll get to that one just like I want to get a sub 4 before I do that. To get a sub 1, you just go to the first term of the sequence, which is 180. To get a sub 4, you can go to a sub 3 and divide by 2, because we know we need to divide by 2 every time. So that's 45 over 2, which is 22.5. And if you go to a sub 5, you can take 22.5 and divide by 2, which will give you 11.25. So notice how I didn't even use my explicit function, just because for me it was kind of just easier to take this, divide by 2, divide by 2. So now if they asked for something like a sub 15 or a sub 10, I would definitely have plugged it in because it had been easier at that point, because you just put that number there, punch it in your calculator, ready to go. Moving on to 3 and 6 there at the bottom. Notice I already have some things down. Let me explain where those come from. On 3, we have a particular sequence that starts at 8, and it has a pattern of timesing by 2 every time. So my common ratio is going to be 2. So once you have that, then you just need to write your function, which for the geometric sequences goes like this. A sub n is your initial value, open your parentheses, times your common ratio to the n minus 1 power, and that's it. You're good to go. And so now you can actually use that to get things like a sub 5, 10, etc. And so to get a sub 10, I took this function and put the 10 in where the n goes, and compute that out, you get 4096. And for a sub 12, you take 12 and you put it where n is, and then you compute that, and you'll get 16,384. And so, yeah, just let your calculator do all that crazy work for you. To get a sub 3, you can just look at your sequence. It's the third one, 32. If you want to get a sub 5, you can just take a sub 4 and times it by 2 because the pattern is timesing by 2. And if you do that, you're going to get 128, which I find a little bit easier than trying to like plug things into the calculator because I just happen to know those sort of things. And when you get to the next one, on number 6, this pattern is timesing by 3 every time. So the common ratio is 3. The initial value is the first term in the sequence, which is just 7. And you're going to use the same form that we did before to get your function. A sub n is your initial value times your common ratio to the n minus 1 power. And that's it. There's your function. Okay, that's going to go the explicit part. To get a sub 10, you're going to take 10 and put it in for n and compute it out. You'll get a fairly large number. To get a sub 9, you put in 9 where n is and you compute it. You'll get also a fairly large number. If you want to get a sub 3, just look at your sequence. It's the third one. If you want to get a sub 5, you can just take a sub 4 and you times by 3 because the pattern times by 3. And so when you compute that, you're going to get 567. Alright, moving on to the next part. So number 4 and 5. On number 4, we start at 2, and it's a pattern of timesing by 4, so your common ratio is 4. Your initial value is 2. And so your function is going to be a sub n is initial value times common ratio to the n minus 1 power. If you look at your notes, it'll give you that. And that's how I got the next two. When you put in 10 and you put in 15 and compute, you'll get these fairly large numbers. One of them is about 500 million. The other one's about 500,000. Anyway, if you want to get a sub 3, it's just the third term in the sequence, which is 32. If you want to get a sub 5, you can just take a sub 4 and times that by 4, which would give you 512. And that brings us to the last one. Initial value is 40. The pattern is dividing by 2, so your common ratio is 1/2. So your function is going to be a sub n is initial value, 40, times 1/2 to the n minus 1 power. And so there's your explicit function for this one. If you want a sub 2, just get the second term of the sequence, it's 20. If you want a sub 1, you get the first term of the sequence, which is 40. If you want a sub 4, you get the fourth term of the sequence, which is 5. Those are just pulled right out of the sequence there. And if you want a sub 5, you can take a sub 4, which is 5, and divide by 2. Hey, it's 5/2. The end.